mission. Our mission does not work if the people on Earth are dead by the time we pull it off.
Well, we got this far, farther than any human in history.
Well, not far enough. Make it count.
Where's the mountains?
Those aren't mountains. They're waves.
I'm not gonna make it!
Yes, you are. Yes, you are.
You might have to decide between seeing your children again
And the future of the human race.
We'll find a way. We always have.
Hi, welcome back for our third and final installment of Movie Science. In our first two episodes, we investigated the world of superheroes, their powers and abilities, and if there are any real-world possibilities of those powers. On this episode, we will veer away from the superheroes and take a look at the movie Interstellar and the possibility of wormhole travel. In the movie, Earth's been almost run dry of its crops. Matthew McConaughey plays an ex-NASA pilot named Joe Cooper, whose old professor reveals to him that a wormhole was discovered that leads to a distant galaxy, billions of light years away. In this galaxy appears to be a number of potentially habitable planets. Without giving too many spoilers away, Joe Cooper and his crew travel through this wormhole to explore these planets. So the questions we're asking today are, what is a wormhole? Do they exist in the real world? And is it possible to create an artificial wormhole?
A wormhole is a theoretical passage through space-time that could create shortcuts for long journeys across the universe. Wormholes are predicted by the theory of a general relativity. But be wary, wormholes bring with them the dangers of sudden collapse, high radiation, and dangerous contact with exotic matter. In 1935, physicists Einstein and Nathan Rosen used the theory of general relativity to propose the existence of bridges between space-time. These paths, called Einstein-Rosen bridges, or wormholes, connect two different points in space-time, theoretically creating a shortcut that could reduce time travel and distance. Wormholes contain two mouths, with a throat connecting the two. The mouths would be most likely spheroidal. The throat might be a straight stretch, but would also wind around, taking a longer path, more than a conventional route might require. Einstein's theory of general relativity mathematically predicts the existence of wormholes, but none have been discovered to date. A negative mass wormhole might be spotted by the way its gravity affects light that passes by. Certain solutions of general relativity allow for the existence of wormholes where the mouth of each is a black hole. However, a natural occurring black hole formed by the collapse of a dying star does not by itself create a wormhole.
Everybody ready to say goodbye to our solar system? To our galaxy. Here we go.
Wormholes are possible according to Einstein's theory of general relativity. Anything being able to travel through one or create one is systematically impossible due to two main components. One component is that our technology is not advanced enough to replicate the theoretical equipment needed to create a wormhole. Even if we had the knowledge to build this kind of technology, it would be extremely time-consuming and cost-worthy to even attempt creating a wormhole, let alone traveling through one. Since no one knows for certain about the dimensions of a wormhole, there is no knowing of how to create one.
If wormholes existed naturally in the universe, they would be small and would most likely evaporate as soon as they are formed. Something as simple as a single light photon would disrupt the gravitational structure of the wormhole, causing it to break down and dissipate. The only way a wormhole could exist is if it had something to focus and defocus light as the light enters and exits the wormhole. This thing would have to contain negative energy density, which also does not exist. All matter in the universe has positive energy density. Therefore, wormholes allowing us to travel at the speed of light across galaxies cannot exist according to our laws of nature.